Okay, and the way, so someone asked, is there a program to use to kind of open the notebooks? And the program is, you have to use Jupyter, okay? And so you have to start up Jupyter using, either the prompt or whatever it might be, and then you open up the notebooks from within Jupyter. There's not going to be like a native thing that you can just open up these notebook things, Word or whatever it might be. Okay, so today we'll take a look at Numpy, and all right. So this is important. Follow the convention. Import NumPy as NP. That's the standard. That's what everybody does. You do something. I mean, technically in Python you are allowed to import it as whatever you want, but you will confuse other people. Okay. So import NumPy as NP. I guess you can just also do import NumPy, and then you have to type out NumPy. That won't confuse people. But generally, import NumPy as NP. That's pretty normal. And here, let me. What I'm going to do is I'm going to restart and clear all outputs. This is what we'll do. Okay, so we'll start off. You run import NumPy as NP. This might take a moment to execute, and then you can kind of see what version of NumPy you have. I think this is the latest, and if you have anything with smaller numbers, you might consider running conda update on just everything. That's generally what I do, but whatever. Okay, I mean, probably not a ton has changed. Okay. All right. So so NumPy arrays they look kind of like lists, like Python lists, except they have to contain all the same data type. So much like in R, where you have a vector and you can't have different data types in a vector, in a NumPy array you cannot have different data types. Okay, they will all get coerced to be the same. Whereas a list, you can have different things. You can have strings and booleans and integers and floats. But with NumPy arrays, they all have to be the same data type. So here, I'm going to create a NumPy array. And the way you do this is you basically write np.array, or np.array, and then inside the array you put in a list, okay? Or some kind of structure. So a tuple will also work here. Okay, you can't just put numbers in directly though. You have to put some brackets here. Okay, and then when you do that, you get back the object. It'll say, all right, I've made an array. Okay, and so if you wanted to store this, you've got to store it somewhere. So here I've got a is equal to NumPy array, and then I say print out a, and when you print out a, it looks like this. Okay. How does this array, how does it differ from when we ask to print out a list? So if I create a list, which will look like this. Exactly. So when you create a list, it has commas in it. Okay. So, and if I say print this out, okay, so this is what a list looks like. This is how an array prints out. So an array doesn't have any commas, whereas a list does. Okay. Yes.
Is that because it's supposed to be rows and columns, or is that just the way it prints?
It's just the way it prints. Okay. So, because ideally by seeing how something prints out, you can try to figure out what kind of structure it is, right? So dictionaries have curly braces, tuples have parentheses or curved brackets. An array has square brackets but no commas. So that's just Okay, so anyway, that's what we have. And then if you ask what's the type on A, it'll say it's a numpy.nd array, n-dimensional array. Okay, and so here I just want to show you, if I make a list with 1, 2, and 3.0, where 3.0 is a float, it upcasts everything, or same idea as coercing, and you get a 1 dot, 2 dot, and 3 dots. So these are now floats because they now have dots in there. Okay, and then if something is a string, everything gets converted to string. Here, let me. I'm going to go ahead and I'm going to just modify this. I'm going to throw in a false, okay, or maybe a true. Okay, and you can see how they get upcast. And if I throw these in there, they'll get upcast as such. All right, you can also you can have a list of lists. Okay, and this will create a multi-dimensional array, right? As long as the dimensions align. So here I've got this, right? And let me just show you what this looks like. So when you print out a list of lists, this is how a list of lists look like. But when you make an array out of it, it looks like this. Okay, so this is basically a 2 by 3 matrix. Okay, let me get rid of this. Okay, but if you don't have dimension match, so I have 1, 2, 3, comma 4, 5, then you get an array of lists. Okay. Oh, I guess I could have done this also, where if one of these things so if I have a string and then one of these will be a list object. Here, I'll just do this. Okay. Did I break something? No. Setting an array element with a sequence. Okay, maybe I'm not allowed to do this. Okay, all right, never mind. I've never tried this, and apparently you can't. I can't embed a list within the array. But here I have an array of lists, which is probably not quite useful. Okay, so this is probably your standard way of making an array. Probably I'll show you a little bit later. Here's a few other ways to make arrays. There's a zeros function. Okay, numpy np.zeros, and this will make a bunch of zeros. Okay, and then the default when you call for zeros is to make floats of zeros. If you want integers specifically, you can call for integers as well. Okay, and then and here, if you provide the zeros function a list of dimensions, or even a tuple of dimensions, it will produce an array or a matrix of those dimensions. So here, 2 rows and 4 columns. Okay, and then you can create higher dimensional objects. So if I do 2, 3, 4, we'll get a 3-dimensional object, and this will be you're going to get 2 like sheets of 3 rows and 4 columns each. Okay, and then over here would be a 4-dimensional object, and we can visualize this as having 2 3-dimensional objects, or like a bunch of 3-dimensional objects. And so in this case, I would have 2 blocks. Each block has 3 sheets. Each sheet has 4 rows and 5 columns. Okay, and that's what I have. So this would be block 1. of 3 sheets, 4 rows, and 5 columns, and this would be block 2 of 3 sheets, of 4 rows, and 5 columns. Okay, so that's all the zeros functions. You have the exact same thing, but you have ones instead, np.ones. So everything that worked with the zeros functions will apply also for the ones functions. Yeah.
Is there end to the hierarchy, or you can keep going?
Yeah, there. As far as I know, it can keep going. I haven't tried it. I mean, I don't know. Is there a dimensional limit to the array function in R? I haven't attempted to. I haven't needed to go into the realm of really more than 2 dimensions probably. Okay, but the option exists. Okay, and then if you wanted something other than 0 or 1, you can use np.full, and you provide the dimensions of the thing you want, and then the value you want filled in. Okay, so you specify value. So here it's going to create 2 rows, 3 columns, a matrix of 2 rows and 3 columns, and it's going to fill in the value 1.2 everywhere. Okay. So this is just array creation in terms of like zeros or ones. Okay. All right. Sometimes you want random numbers. Okay. So like, in R we have R unif and R norm and all of that. In NumPy, you use numpy.random and then the function name. Okay. If you want reproducibility, you can set a seed, and so you use numpy random seed, and you just put in your number, much like set seed. So you just do that, np.random.seed, and this will set what it is. Okay, so random is the same as RUnif. It's the random uniform. Okay. Yeah, you might ask, like, why do I have to write np.random.everything? It's just so within the you have to think of Python and all of its modules arranged kind of like a table of contents, and there's like a hierarchy to these things followed, a bunch of things. So you'll have like the random segment within NumPy, and then there's a bunch of things within there. And so you could, if you wanted to, you could say import np.random as R or something, whatever it might be, and then you can you'll have a shortcut to type that out. You don't have to keep typing everything like this, but anyway, this is what we got. So np.random will be just random uniform numbers from 0 to 1. Okay. Rand n will be from the standard normal. So if I ask for 5 values from the standard normal, I get values like that. Okay, so not from the interval 0 to 1, but negative and positive numbers, and we'll see values bigger than 3 not very often. If you wanted to specify exactly like your mean and your mean and standard deviation, you can use random.normal, okay? And this will say you specify your mean, standard deviation 3, and then here I'm providing it dimensions 2, 4, which means I want it to make a matrix with 2 rows and 4 columns. Okay, and so here I get I get values between around 6 to I don't know, whatever else. Okay. Okay, and I had a 2-dimensional thing. You can do the same thing with any of these things. So when I ask for a random uniform, I could put in 2, 4, and it will produce a matrix. Or I guess technically it's an n-dimensional array of dimension 2 and 4. Okay, and then random int will produce random integers, and so here it goes from 0 starting at 0, ending at 10 exclusive. So basically the digits 0 through 9 only. And then I want 20 values. Okay. So if I wanted to do simulate dice rolls, what would I do? No. So I'm just rolling a die. What would I do? Yeah, I do randint from 1 to 7, and then however many I want, 50 of them. Okay, and these would be random dice rolls. Okay, there's a whole bunch more. You can click the documentation, and pretty much all the probability distributions you learned about, and many that you haven't learned about, they're there. So you can do beta, binomial, chi-squared, Dirichlet, exponential, whatever. Okay, but probably your most common ones will be the uniform and the normal. I don't know, whatever else, right? So, and then the there you go. Okay. Okay. But probably the most common array that you'll make will be the array range. Okay. So regular old Python has the range object. Okay. So if here I do range 0, 10, 2. That creates a range object starting at 0, ending at 10 exclusive by step 2, right? So, and then if you actually want the values themselves, you have to throw it into a list. So what numbers will show up in this list? What will I get? Range 0, 10, 2. 0, 2, 4, 6, 8, right? Okay. In Python, we have basically the same thing, except, here, let me just do the same numbers, 0, 10, 2. This is, you use a range, so for array range, okay, and it'll make a, whatever, it'll make a Numpy array with whatever it is that you want, okay? So a range for array range, but yeah, big. Numpy a range will be, whatever you want, 0 to 100 by 5s, okay, 0 to 95. So, I mean, it's equivalent of basically, if I did np array of range object 0, 10, 2, okay? This is the equivalent to this, but equivalent quote manual creation using just the kind of the more primitive make an array out of this thing, but probably a range is something you want to be familiar with. Okay. Okay, and then the other very handy thing is linspace. Okay, and so so here linear spaced values starting at stop, ending with start. You go from start to stop with the length of the number. Okay, the stop is included. Okay, stop is inclusive here. Okay, so here linspace 0, 111 will go 0 through count by tens, 10, 20, 30 up to 100, and there's 11 values and they're all evenly spaced out. Okay, so if I did linspace 0, 110, what will happen here?
0, 9, 11.
So there, 0, 11.1, 22.2. So, you're going to get an array of total length 10 starting at 0 and going to 100, okay? Evenly spaced out. If you don't want to include the endpoint, you can say endpoint equals false, and then it will evenly space them out. So, you know, just let me just kind of, what will 'This do? 0, 111. Okay. Each one is 1/11th of the way, and then, you know, you miss out on the last one there. I don't know, maybe I should just do 9, okay? And then you'll get this basically the same thing as what happened before. So, you know, depending on what your what this thing is, and if you're excluding the endpoint, you know, the last value on the linspace array might be different, right? The last value here is 90, and the last value here is 88.8. Okay. So generally, I just leave in the endpoint. Okay. So I'll say if you use the endpoint argument, the last number in the array will depend. Oops. The output length. Okay, there you go. All right, so those are just ways to create arrays. Probably, yeah, linspace and arange. I'd say those are probably my two most commonly used things. Because often, you know, you just want like 1 through 100 or something. Wait, is there? Let me just see. np.arange 12. Yeah. So this is probably like the quickest. Let me move this up. So if you want like 0 through 19, just arange 20. Makes it quick. Okay, array attributes. So arrays have a shape, and they also have, you know, number of dimensions, the data type, and the shape. So if you want to know the, so this is one thing you got to kind of get used to, because you know, when I'm switching between R and Python, my brain gets confused, and sometimes I'll find myself typing, you know, Python commands into R or R commands into Python. And so in R, you ask for like the dimensions of a matrix, okay? With arrays in Numpy, you ask for the shape of the object, okay? So here, X looks like this. This is the matrix that we have for X. It has 3 rows and 4 columns, okay? ndim is the number of dimensions, so what will this return? 2, right? Because it's a matrix. It's got rows and it's got columns, so it's 2-dimensional, okay? Its shape, which is, you know, we're used to calling it the dimensions of the matrix, but the shape of the matrix, or I should say the shape of the array, is 3 by 4. 3 rows, 4 columns. And then the data type, what kind of values are stored in this array? Floats, okay? And Numpy is specific, and it says float 64, meaning kind of the double precision float. We use 64 bits to store the value of the float, so that's kind of your standard float. But if you wanted, I don't know, for whatever reason, optimize things for memory or something, which you probably wouldn't use Python for anyway, but if you wanted to like use smaller things, you could specify float 32, and that will be like single precision floats and stuff like that. Similarly for integers, the standard integer uses 16 bits to see how many things you can have, and but I don't know. So you can specify different. Let me see. NumPy data types. This is probably unnecessary to check. What are my options here? Okay. So these are all the options you can have. Integer, depending on how many, I guess integer 32 is probably our most common one, but you can have integer 64s. Same thing for floats. Oh, you can have unsigned integers. Okay, well anyway. Nobody cares. Okay. Just the default's probably good enough. All right, so that's that. Here, I'm going to create an A range 0 through 12, 1. This is the same thing as NP range 12. Okay. All right. How many dimensions does this object have? It's only got one. Okay. It feels weird, but it's only got one dimensional because it's like a vector, right? It's a vector. No, it only has a length. There's no number of rows. Okay. And then when you ask for the shape, it gives you back this tuple to kind of indicate that there's only one value here, okay? So it just has a length of 12 and no other dimensions to it. All right, so then once we've established that, okay, so we've got some matrices, or you know, the arrays can have multiple dimensions, as we saw. You can have 3, 4, probably a lot more dimensions, but generally we're working either in 1 or 2 dimensions. Okay. When it looks like this, we've got 2 dimensions. When it looks like this, we've got 1 dimension. And okay, we have a tool called Reshape. Okay, so here I'm gonna recreate my vector. It's got 0 through 11, and I can use np.reshape. So numpy.reshape, put in j, and say I want to reshape it so it has 3 rows and 4 columns. Okay, I'm going to call this k. So I'm going to say np.reshape j into 3 rows, 4 columns, and it fills it out. Okay. One thing to note is that when you use this reshape command, NumPy fills it out row-wise. Okay, in R we're accustomed to things filling out column-wise for the matrices. Here we're getting them row-wise. Okay, so the values 0 through 11 get arranged as so: 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, and this command reshape leaves the original array unchanged. Okay, so the array is still 0 through 12, or I'm sorry, 0 through 11 as a vector. Okay, as a one-dimensional array. Okay, you can also just call the reshape method directly on the object. Okay, so here I said numpy.reshape and I gave it the object j. But I can also just say j, which is an array. I want to reshape this to have 4 rows and 3 columns. Okay, and it says okay, and it gives me back 4 rows and 3 columns. But this again, this will return a copy. This is a new thing. This is a new object, and the original j is left unchanged as well. Okay, so unlike lists where if you append or extend it, it actually modifies the list. Here, the arrays, the reshape method returns a new object that's separate. Okay. So here is k. K is the array that we created earlier. 3 rows, 4 columns, arranged like this. The transpose is just k.t, and then it transposes the matrix exactly as we would expect. Okay, And again, calling k.t does not modify the original k. So these things are left unchanged. Right? So you can call k and k transpose, and that's fine. Okay, and then so you know, if you want to, you can kind of string the methods along and do this. So here I'm saying make a range object from 0 to 12, so basically 0 through 11. Reshape it, 3 rows, 4 columns, and then transpose it. So I can just string all these things along each other, and it will return back 4 rows and 3 columns arranged column-wise. Okay, once again, the shape of this is 12. If I ask for y and I ask for it to transpose, what do you think this will do? Okay, it remains a one-dimensional array. Okay, because it only has one dimension. Okay, so the shape of y is length 12, no other dimensions. And if I ask for it to transpose, you know, we can't really switch the dimensions with anything, and so it remains length 12 with no other dimensions. So they still remain just one-dimensional vectors. Okay. This is a subtle change, but here I've reshaped y to have 2 dimensions, 1 row and 12 columns. Okay, and so now it looks like this. Right? In Python or in NumPy, if you count the number of square brackets, it's a hint for how many total dimensions there are. Okay, so when we have this crazy looking array, we have 1, 2, 3, 4 square brackets at the beginning and 4 square brackets at the end, indicating that there's 4 dimensions. Here I've got 3 square brackets in the beginning and 3 square brackets at the end, so I've got 3 dimensions. And then pretty much all the matrices that have 2 dimensions will have 2 square brackets. So it's a very subtle shift, reshaping the basically the vector, the one-dimensional array, to a 2-dimensional array. Okay, so they look almost the same, but this has a second square bracket. So if you see this, you know it's a 2-dimensional object. Okay, and so I've got 1 row, 12 columns, and if I ask for the shape, it's going to say it's 1, 12. Okay, and then so if I transpose this, now that it's a matrix with 1 row, it's an array or a matrix with 1 row and 12 columns. If I transpose this, then it becomes 12 rows and 1 column. And if I ask for the shape, it says accordingly 12 rows, 1 column. All right. So I think, because in R would like coerce, like if you give it a vector and you feed it into transpose, I think it coerces it to a matrix and transposes it, if I'm not mistaken. But Python behaves differently, right? So we just have to kind of get used to these things, but these are things you can do. And so now we have the arrays. Okay. Are there questions on this? Is all okay? All right. You can subset and slice arrays, much like subsetting and slicing lists. And so here we'll just kind of start off with our a range 12. And here I ask, what is the object at index 4? So it's going to be the 5th object in the thing, and that takes on the value 4. Okay. So again, it's one-dimensional, length of 12, and you can slice it from objects, basically slice from 4 to 6. So what will this return if I slice from 4 to 6?
4 and 5.
4 and 5, exactly. Okay. Because we're slicing basically from the 4th comma, which doesn't show up in arrays, but and up to the 6th, that we're going to get just 4 and 5. Okay. You can also slice with a second colon, okay? And then it becomes basically start, stop, and step size. And so here I can say slice from index 1 to index 8 using a step size of 3. So that's going to give us 1, 4, and 7. So you can get, you know, odd numbers by using a slice, right? So if I wanted to just, I can do np.arrange 100 and slice. If I wanted the odd numbers, I would do 100, comma 2 like this. And if I wanted the even numbers, I would just leave off the first part and it would start at 0. Whatever. Okay. Shortcut to get values. I don't know, however you want to do it. All right. You can subset or slice a higher dimensional object. Okay. Similar to R, in that you specify 2 dimensions, 2 values, right? A row and a column. So here I just reshaped Y so it's a matrix, okay? 3 rows, 4 columns, and this says give me back the object in row index 1 and column index 2. So what value is that? Row index 1, column index 2. It's going to be the value 6, right? Row index 1 is the 2nd row, column index 2 is the 3rd column, 6. Okay? And if you ask, you know, what's this type, it's going to just tell you it's an integer. It's no longer an array. You can do slices. You can say I want from row index 0 up to 2, so it's going to just give us the first 2 rows and then the first 2 columns, right? So it's going to give me 0, 4, 1, 5 or 0, 1, 4, 5 right here. And if I say, what is this? What kind of object is this? This is still a Numpy array. Okay. If you want the entire row, you say, I want row index 2, and then you put in a colon for, to say I want all the items in index 2. Let me just, what happens if I guess you can also just leave it blank. Okay. Yes.
Would the type of that be list or an array?
This is an array. Okay. So if I just say print the type of this thing, it's still
Oh yeah, right.
it's an array. Okay. Except it's a one-dimensional array. Okay. Because now that I said I only want row 2 or row index 2. It only has a length value for its dimensions. Okay, and then similarly we can get columns, and they are one-dimensional as well. Okay, here's an important thing, is that the slices of Numpy arrays, they are views, much like do you remember the dictionary view thing? And so with a dictionary view, the view object updates dynamically when the original object is updated. Okay, and similarly, when you slice an array, they are view objects and they update when you have this, right? So actually, I'm going to just, this will be Okay, so here I've got Z. It's 0 through 11, arranged in 3 rows, 4 columns. And I'm going to say I want basically this 2 by 2 top corner up here, okay? So I'm going to create a new object called Z sub. It's like a sub array asking just for the top corner, okay? So this is my sub array. And so here I'm going to modify this value 0, okay? Index 0, so row and column 0. I'm going to change that to 99, okay? And then if I ask what is the subarray, without having to redefine it or anything, the value has updated to 99, okay? Okay, and so, you know, this is something like that. Okay, if I did this though, oh, 3, 5. Okay, and then I said, all right, print Z sub. What will appear here? Okay. Why didn't this get updated after I said Z is a new array?
It's a new object?
Yeah, this is an entirely new object, okay? So here, Z gets redefined to an entirely new object. And so Z sub, so we are not modifying it, we're just associating the name Z with an entirely new object, okay? So we are not modifying the object that used to be called Z. We created a new object, and the name Z now points to the new object. Okay, so therefore the Z sub, the view Z sub still points to the, you know, object formerly known as Z. Which was not modified. I don't know if that makes sense, but that's what's happening. Okay, so in the beginning here, I'll just kind of start at the beginning. We're gonna, you know, here I'm creating an array from 0 through 11, and we're calling it Z. Okay, and then I'm subsetting that, creating a view object based on that, and so this Z sub is pointing to this object called Z. And then I modify that object Z, and then so the view updates, okay? If I do this, I'm not modifying Z. I'm just breaking the name association. Z is pointing to an object right now, it's a name, and when I use this equal sign, I'm basically, over here I'm creating a new object that has, I don't know, 15 elements in it, and I'm saying, you know what, this name Z is now going to point over here. This object that was up here, this actually still exists somewhere in memory, I think, and I can reference it using something, I don't know. And so this remains unmodified, okay? If I had extended Z, on the other hand, to 15 and rearranged it or something, then it would change. So here I'm completely breaking the association here between Z and the object. Okay. So, but anyway, if you want a copy that will not update, if the original is updated, you can use array copy. So here, this is what Z looks like. I can say I want the sub thing, the top left corner dot copy, and so this creates a copy of this. If I modify the top left corner to 55, the copy remains unchanged. Okay, but print z, this has 55. Okay. Okay, we're gonna run on time, but I think this is enough time to cover this topic. So concatenating arrays, so a lot of times you want to bind rows together or bind columns together, merge things together. Okay, we can do that. So here I've got an array 0, 1, 2, 3 and 100, 101, 102, 103. Okay, concatenate will stick them together. Okay, you can concatenate them along axis index 0 and you get the same thing. All right, concatenate along axis index 1 throws an error. Okay, it throws an error because if we look at the shape of one of these objects, there's only one dimension, right? So we only have an index 0, we don't have an index 1. Okay, so we can't do that. Okay, you can use the command vstack, vertically stack, and this is probably what we want to achieve, 0, 1, 2, 3 stacked on top of 100, 101, 102, 103. Okay. Here I'm creating two objects, two matrices, 0 through 5 and 100 through 105. When you concatenate the two, they get stacked on top of each other like that. Okay. You can use concatenate along axis 0, which is row-wise, because if we think about what if we ask not the dimensions, but the shape of this object, shape of these, it would say 2, 3, right? And so along axis 2, which refers to the rows, we're concatenating them row-wise, okay? When I say axis equals 1, that will concatenate along the columns, okay? Because you just have to think index 0, when you ask for the shape is reported as rows first, then columns. So index 0 refers to rows, concatenate row-wise. Index 1 refers to the columns, concatenate column-wise. Okay? And then likewise we have vertical stack and H stack. If you can't remember axis 0, axis 1, you can also just use V stack and H stack, and it will stick them that way. Yeah.
Is there a reason it created 6 columns as opposed to 3?
What do you mean 6?
Yeah, along the axis.
Because I said axis, I want to concatenate them, right? So I have two matrices. Both of them are 2 rows, 3 columns. Okay?
Okay.
So I have the option of sticking them on top of each other, or I can stick them side to side.
Yeah,
okay?
go all the way.
Yeah, so axis 0 will stick them on top of each other, and so I'll have 4 rows and 3 columns. Okay? Or axis 1 will stick them side by side, and I'll have 2 rows, but now 6 columns. Okay, so both options exist, and you can achieve that also using V stack and H stack. All right, we'll look at the math operations next week. Okay, we'll have a quiz on Monday, and the quiz on Monday will cover I would say the Python stuff. So don't worry about this NumPy stuff, but I would say look at the notebooks and kind of the Python stuff that's been covered. So you can look at the data camp stuff on Python and then the notebooks that I've written. Okay, we'll end there.